Hello, students. Welcome. Today we're going to do a very quick and hopefully a very calm revision of one of the most important chapters in your chemistry syllabus, acids, bases, and salts. The idea is to just go over the key points step by step so you feel confident and ready for your exams.
So, here is our roadmap for this session. First, we'll quickly recap the basics. What are acids, bases, and indicators? Then, we'll look at the key chemical reactions. This is very important. After that, we'll touch upon the role of water, why it's so critical, and then understand the power of pH. We'll have a quick look at salts, and finally, I'll give you a simple plan to revise this chapter effectively.
Okay, so let's begin with the very first topic, the basics. How do we even identify if something is an acid or a base? Let's refresh our memory on that.
Now, you'll probably remember this from your earlier classes, right? We learned that acids, well, they generally taste sour. Think of a lemon. And bases, they tend to be bitter, like if you've ever accidentally tasted baking soda water. But in chemistry, we don't taste things. So the most common test we use is the litmus test. And this you must remember. Acids turn blue litmus to red, and bases turn red litmus to blue. A very simple but very fundamental concept to start with.
So these substances, like litmus paper, that help us indicate whether something is acidic or basic, what do we call them? Well, quite simply, they're called indicators. An indicator is just any substance that changes its color in an acidic or a basic medium. And, they can be natural, like litmus itself, or even turmeric, haldi from your kitchen. But we also have synthetic or man-made indicators that we use in the lab, like phenolphthalein.
Okay, now, please pay very close attention to this slide. This table is extremely important from an exam point of view. Questions on these color changes come up all the time. You absolutely have to memorize this. For example, look at phenolphthalein. It's colorless in an acid, but it turns this beautiful pink in a base. And methyl orange? It's red in acid and yellow in a base. I would suggest you even pause the video right here and make sure you know this table by heart. All right, let's move on to the chemical reactions. Now here's a small tip from my side. Please, do not try to memorize every single reaction. That's not the smart way to study chemistry. Instead, focus on understanding the general patterns. Once you know the pattern, you can predict the products for any similar reaction they give you.
So, here's our first general pattern. When an acid reacts with a metal, what do you get? You always get two things, a salt and hydrogen gas. It's a simple displacement reaction, you see. The metal kicks out the hydrogen from the acid. A very predictable and important reaction type.
Okay, so the reaction produces hydrogen gas. But how do we know for sure? Well, there's a standard test for it. What we do is we collect the gas and bring a burning splendor or a candle near it. If it's hydrogen, you'll hear a characteristic pop sound as it extinguishes the flame. Please remember this test. The pop sound test for hydrogen is a classic favorite question for examiners.
Now for our second reaction pattern. This one is for when an acid reacts with a metal carbonate or a metal hydrogen carbonate. The products here are always the same three things: a salt, water, and carbon dioxide gas. Here's a little trick to remember. If you see a carbonate in the reactant, you will always get carbon dioxide as a product.
So this time, we're getting a different gas, carbon dioxide. Now, I want you to think for a second. Do you remember the test for carbon dioxide gas? Take a moment to recall before I show you the answer. Were you able to remember it? The standard test is to pass the gas through lime water, which is just a solution of calcium hydroxide. If the gas is carbon dioxide, that clear lime water will turn milky or cloudy white, and this happens because of the formation of insoluble calcium carbonate. This test, the lime water test, is just as important as the pop sound test. You must know.
And finally, our third key reaction pattern, which is probably the one you've heard of the most. What happens when an acid and a base react with each other? Well, they cancel out or neutralize each other's properties. That's why this is called a neutralization reaction. And the products are always the same, a salt and water.
Okay, so we've seen what acids and bases do, but have you ever thought about why they behave the way they do? What is the secret ingredient that gives them their powers? Well, the answer is something very simple and very common: water. Let's look into this a little more.
This is the core concept, so listen carefully. An acid is only an acid when it's dissolved in water. Why? Because it's only in water that it can release hydrogen ions, the H+ ions. The same goes for a base. A base shows its properties only in water, when it releases hydroxide ions, or OH- ions. So it's these H+ and OH- ions that are responsible for all the acidic and basic properties we've talked about. No water, No ions, no acidic or basic character.
Now, talking about dissolving things in water brings us to a very, very important safety procedure. When you mix a strong acid with water, a lot of heat is produced. It's a highly exothermic process, so you have to be very careful. And the rule is, always add the acid slowly to the water, while stirring constantly. Never ever do it the other way around. Never add water to a concentrated acid. The heat can be so great that it will cause the solution to splash out and give you a very serious acid burn.
And this is why you will often see this warning sign on bottles of concentrated acids and even strong bases. This symbol means the substance is corrosive. It can literally eat away at your skin, your clothes, or the lab bench. So whenever you see this sign, you know you have to handle that chemical with extreme care.
Right. So we know what acids and bases are. But are all acids equally acidic? Is all soap equally basic? Of course not. Some are strong and some are weak. So how do we measure this strength? For that, we use a special scale called the pH scale. The pH scale is basically a scale of numbers from 0 to 14. It's quite simple to understand. Right in the middle, at pH 7, we have neutral substances, like pure water. Anything with a pH less than 7 is acidic, and the lower the number goes towards 0, the stronger the acid becomes. Anything above 7 is basic or alkaline, and the higher the number goes towards 14, the stronger the base is. And this isn't just some abstract chemistry concept. pH is incredibly important in our daily lives. Did you know our own blood has to be kept in a very narrow pH range, around 7.4 for us to survive? You've heard of acid rain, right? That's when rain's pH drops below 5.6 and starts harming plants and fish. Even your own stomach produces hydrochloric acid with a very low pH to digest food. So you see, pH is everywhere. Now, throughout this discussion, we've been using the word salt. We said acid plus metal gives salt and hydrogen, acid plus base gives salt and water. So, let's take a moment to properly define what exactly we mean by a salt in chemistry.
In simple terms, a salt is an ionic compound that is formed from a neutralization reaction. It's what you get when the H+ from the acid combines with the OH- from the base to form water, and the remaining ions join together. Of course, the most famous example of a salt is sodium chloride, NaCl, which is the common salt we use in our food.
All right, we have covered the entire chapter very quickly. Now for the final and perhaps most useful part, let's summarize all this into a simple checklist, a revision plan that you can use to prepare for your exams. So here are the 5 most important things you need to focus on. Number 1, understand the general reaction patterns. Don't just rote learn equations. Number 2, once you know the patterns, practice writing and balancing the chemical equations. Number 3, that table of indicators and their color changes, you must memorize it. Number 4, the gas tests. The pop sound for hydrogen and the lime water turning milky test for carbon dioxide. Be absolutely clear on these. And finally, number 5, understand the pH scale. What is acidic, what is basic, and what the numbers mean.
Just remember, the key to chemistry is not just memorizing facts, it's about understanding the underlying patterns. If you focus on these 5 points that we've just discussed, you will be in a very strong position. Just revise these concepts once more, and I'm sure you will do wonderfully. All the very best for your exams.